Imagine standing in front of a mirror. The image you see looks just like you, but reversed. This is Suzanne, Blender's classic monkey head, facing away from a mirror. What you see is a reflection, but nothing actually exists behind the mirror. It's just a visual effect. Let's take a look from another perspective. In 3D and 2D diagrams, we see that there is no object behind the mirror. The mirror doesn't create matter, it creates symmetry. This is the foundation of how we define reflection in crystallography. Now imagine two identical atoms, or even two Suzannes, moving in opposite directions. As one moves to the right, the other moves equally to the left. They are related by mirror symmetry. What happens to one, happens to the other, but mirrored. When we compare this motion in both 3D and 2D, we see that the reflection symmetry creates a perfect inverse along the mirror plane. One position becomes the mirror of the other. This is key in crystallography. Every position has an equivalent partner in the crystal structure. Let's take this further. If we apply mirror symmetry in three different planes, YZ, XZ, and XY, we see how identical atoms maintain symmetrical relationships across each mirror. These mirror planes are like the rules the crystal follows. No matter where you are, there's always a counterpart. Watch closely. Now the mirror is aligned perpendicular to the y-axis, and both atoms move in the x direction, parallel to the mirror. Interestingly, there is no sign change in this motion. This tells us something fundamental. Motions parallel to the mirror plane are preserved. Here's the same idea, but the atoms now move along the z-axis. Again, since they are moving within the mirror plane, there's no reversal. Mirror symmetry only changes the coordinate perpendicular to the mirror, not the ones inside it. Let's summarize what we've learned. Reflection symmetry gives us these equivalent positions. The identity operation keeps x, y, z unchanged. A mirror normal to x gives minus x, y, z. A mirror normal to y gives x minus y, z. And a mirror normal to z gives x, y minus z. These operations are the building blocks of crystal symmetry, simple, powerful, and everywhere in nature.